Hi everyone. Today we are going to discuss a topic related to factor operations. But before we start, I think it's a good idea to review what you have learned in physics, especially related to the difference between scalar and factors. So let me pause for a minute and let you guys think on what is the difference between those two terms, scalar and factors. Well, uh, in physics we have learned scalar versus factors, right? And certainly scalar is only has magnitude, right? Okay. Meanwhile, in the factors, it has both the magnitude and directions. Okay. In this course, usually I will write a factors like this. For example, I call that factor is a v, factor v. So I will put an arrow at the top of that factor. Okay. Meanwhile, for the scalar, I will just write it in a plain manner without any things on the top of the letter. Okay. Okay. So that's the difference between scalar and factors, where scalars only has the magnitudes and factors have both magnitude and directions. Okay. And then the first of factor operations that I would like to discuss in here is related to scalar multiplication and division. Okay, so scalar multiplication and division. Okay, so for example, if I have a factor, let's call that factor A in here, okay, and I multiply that factor by a scalar of 2, right? So basically that multiplications will only change the magnitude of the factors. So right now the length of the factors is twice as its original length given there. Okay, so if the original length is a, then after we multiply by 2, the length becomes 2a. Okay, it also works in a manner when we try to multiply these factors with a negative scalar. For example, if I multiply it with negative 1, right now the factors will change the directions. It will go to the other way. Okay, so right now we have negative a right there. Okay, so in a similar manner we can calculate the factor divisions to a scalar. For example, if I choose my scalar is 1/2 from this a, is originally the original length is a, right now it will be shortened. Okay, and if we multiply by 1/2, it will be shortened by 1/2. Okay, it still have the same directions as we noticed. However, the direction is changing once we try to multiply it with a negative scalar. Okay, although it's still parallel to the one that it before we multiply to its original factor. Okay, all right. So that's scalar multiplication and divisions. I certainly sure that you have you have learned some of this in your physics class, and right now we are going to continue with factor addition and subtraction. Okay, And notice that in here, I'm pretty sure you have learned how to do factor addition and subtractions in using a by using the Cartesian components of the factors. But in here, we are not doing that method yet. Okay, later we will do that method, but right now in here I will try to introduce basically two construction methods, which is basically to construct sketches that can help us to calculate the factor additions and factor subtractions of two or more factors. Okay, so the first constructions method that I introduce in here is based on the triangle rule. Okay, it's based on the triangle rule. So basically, let's say that we have factor A. Let me change let's say that I have a factor A, okay, and then factor B right there. Okay, so in triangle rule, it's basically say you can calculate the factors, the resultant factors as A plus B. Okay, and really in here our purpose is to calculate what is the magnitude of R, right? And also what is the direction of R. Okay, and to help us calculating these two quantities, this triangle rule will provide a sketch that will help us to calculate using a trigonometry law that we will review later. Okay, so let's see what this triangle rule told us to do. Okay, so we have factor A and factor B right here. So basically triangle rule tells us that we move the tail of factor B to the head of factor A. Okay, so we move the tail of factor B to the head of factor A right there. So the resultant factors can be drawn by connecting the tail of factor A to the head of factor B. Okay, this is also can be done in a similar manner. So instead of moving factor B, we can move factor A, which is we move the tail of factor A to the head of factor B. So this is factor B, this is factor A. So the resultant factors is going there. As you can see, these two methods, these two construction or these two sketches give us the same factor R and with the same directions. Okay, if we draw it properly. Okay, and then the second construction method that I would like to introduce here is using the parallelogram law. Okay, using the parallelogram law, and in here let's say consider the same factor A and B, factor A and factor B. Okay, so the parallelogram law basically in parallelogram law basically you have to combine the tail of two factors together. This is factor A and then this is factor B. So you put the tails of two factors together, and then afterwards you draw a line that is parallel to factor B and another line that is parallel to the factor A. Okay, so this line parallel, this line parallel. Okay, that's why in here it's called the parallelogram law. Okay, and then afterwards you can draw the resultant factors R by connecting this point right here and this point right there. Okay. All right. So you can see that if we draw it properly, factor r in here, factor r in here, and factor r in here, they should have the same magnitudes and should have the same direction. Okay. In a similar manner, we can do the same thing for a factor subtractions. For example, right now, if I'm interested in calculating r, let's give it a subscript of r of t is equals to a minus b. Basically, we can calculate this by writing it as a plus minus b. Okay. So what does it mean? It means that we have a factor a, right? Then we have a factor of minus b, which is going to the opposite directions. Let me draw it right there. Okay. And afterwards, we try to calculate the factor additions of these two factors, right? You can use parallelogram law or you can use triangle rule to sketch the resultant factors. However, in here I would like to demonstrate if I use parallelogram law how it looks like. Okay, so I sketch a line parallel to A and a line parallel to B, and then the resultant factors will be here, right? So this is R of t. Okay. And if you would like to, I think it's a good idea to also to show you how to construct it with a triangle rule, right? This is factor minus b, and this is going to be your r sub d. Okay. So as you can see that these constructions, either using the triangle rule or parallelogram law, it will form some sort of triangle that we can use to calculate the magnitude and directions of the resultant factors. So for example, if I'm looking at the triangle rule, basically the triangle that I form in here is this triangle right there, right? This triangle right here. Okay. And then in a parallelogram law, basically it's this triangle right here. Okay. And then basically it's this triangle right here, or this triangle right here, right? Or this triangle right here. So this triangle will be very helpful for us to calculate what is the magnitude of R and what is the directions of R. Okay. And to calculate that, we need to review some of the trigonometry law that we have learned in mathematics and also in physics. Okay. So to review some of the trigonometry law, and the first one is the Pythagoras law, right? And then the second one will be sine law, and then the third one will be cosine law. Okay. So in a Pythagoras law, let's draw a right triangle. Okay. So if this is C, this is A, this is B. Okay. So, and this is a right triangle right there. So we can with a Pythagoras law tells us that c square is equal to a square plus b square. Okay, or you can calculate a square by taking c square minus b square. Okay, and if I have an angle over here as alpha, okay, I know that tangent alpha is a plus b. Okay, and then sine alpha is a, it's not a plus b, it's a divided by b, and sine alpha is a divided by c, and cosine alpha is b divided by c. Okay, So let's check it again. Tangent alpha is A divided by B. Sine alpha is A divided by C. Cosine alpha is B divided by C. Okay, so that's a Pythagoras law, right? Then we move to the second law that we typically use to solve problems related to trigonometry. So we call it sine law. So basically, if I have an arbitrary triangle, okay, it doesn't have to be a right triangle, it can be any triangle, okay, and if I call this side, the length of this side is A, the length of this side is B, the length of this side is C, okay, and then I call this angle right here is alpha, the angle right here is beta, and the angle right here is gamma. Okay, so sine law tells us that sine alpha divided by A is equal to sine beta divided by B. Let's be consistent using A, B is equal to sine gamma divided by C. Okay, that's basically sine law. Okay, and the third law that is helpful later is what we call as the cosine's law, and basically it works for any triangle. So let's say we have this triangle, an arbitrary triangle. The length of this side is A, the length of this side is B, the length of this side is C. The angle here is alpha, beta, and gamma. So cosine's law tells us that C squared is equal to A squared plus B squared minus 2AB cosine gamma. Or we can also write B squared is also equals to A squared plus C squared minus 2AC cosine beta. And A squared is B squared plus C squared minus 2BC cosine alpha. Alright, and these are the cosine's law. And as you can see, this cosine law, when alpha is equals to 90 degree, right? When alpha is equal to 90 degree, these expressions actually become to 0. It collapses and it gives you the same expressions that we written down for Pythagoras theorems right here. Okay, and I think that's it for this lecture. The key important in here is that to find the resultant of two factors, okay, whether it's an additions or subtractions, we can use triangle rule or parallelogram law to help us to get the sketches, right? Only to get the sketches. Afterwards, to calculate the magnitude and directions using that sketches and applying the trigonometry law over here, okay, we will be able to solve what is the magnitude and directions of R. Okay.